Welcome to Math 098, and we're looking at Chapter 3, Section 4, Absolute Value. So there's a couple things I want you to recognize, and for the reason why I'm asking you to look at a graph of this is to help you understand why there's two answers. So the first thing I like to point out is most students are familiar with the absolute value function. Now, I don't know why I chose P, it must have been in the book, but the absolute value function looks like a V shape, and you should have learned that in Algebra 2 before you got to my class, but if not, try different values, like plug in P equals 0, absolute value of 0, 0. P equals 1, absolute value of 1 is 1. P equals 2, absolute value is 2. Same thing with negatives, but the absolute value of a negative makes it positive, so absolute value of negative 1 is 1. Absolute value of negative 2 is 2. So then graph the line y equals 2. Well, y equals 2 is just a horizontal line right here. So why do you have two solutions or two answers is because the absolute value and the horizontal line cross twice. There are two intersection points. Now, the way I like to explain it, and it doesn't work for everybody, but it works for me, is what's inside the absolute value could be a positive number. So it could be a positive 2, and the absolute value of positive 2 keeps it 2. Or what's inside could equal the negative 2, because if P is negative 2, what's the absolute value due to negative 2? Makes it positive 2. And I like to just put and in here. Sometimes, people write or. I'm going to leave that up to you. We'll kind of investigate that, the difference between those. Typically, I would say or if you want. So P equals 2 or P could be negative 2. Okay, so in the next problem, again, I'm going to follow my advice. Now, sometimes I don't rewrite the problem because it's just a habit I'm in. Or what's inside the absolute value could have been negative 5. And think about it. If 2x minus 3 is equal to negative 5, what's the absolute value going to do to it? Make it positive 5. And what I like about these types of problems is the work is the same throughout. Like your first step is to add 3 over. So you have 2x is equal to 8. And then when you divide by 2, you get x equals 4. Or over here, 2x equals negative 2. When you divide, you get negative 1. So those are your two answers for exercise 2. Of course, I'm going to go to Desmos and show you how you can double check your answer. So pause the screen if you're still writing down work. So the next thing you'll see is Desmos. So in the bottom left corner of Desmos is a little show keypad thing. And the reason why I'm showing that to you is because there's this absolute value symbol that you can type in the equation. And now you can just type it in the way it looked. Except I already forgot what the equation was. 2x minus 3. And then in a separate equation, I'm just going to write y equals 5. And what I'm looking for is the points of intersection. And I only care about the x values. The reason why I only care about the x values is because 5 is telling me what the two equations equal. So x equals negative 1 and x equals 4. So I can zoom in and show you a little bit closer. X equals negative 1 and x equals 4. So that's what I mean by checking your work graphically. Now the next one doesn't ask you to do that, so we don't have to. But again, your statement is either what's inside is equal to positive 15 or what's inside, because the absolute value, could be negative 15. Notice I didn't rewrite it this time. I kind of warned you I tend to do that. So x divided by 5 would be equal to 14. And then when you multiply by 5 to solve for x, you get x equals, let's see, 50, and 5 times 4 is 20, so that must be 70. And the same work over here, as I mentioned before. So you have x over 5 is equal to negative 16, but now when you multiply both sides by 5, well, 6 times 5 is 30, 50 would be negative 80. All right. And then the next one, just to add a little bit more work to it, I tell my students to isolate the absolute value. So you don't want to change the sign until the absolute value is the only thing on one side of the equation. And it was on exercise 2 and 3. So you have one step to do before doing what I mentioned before. The absolute value of 3x is equal to 6 now. So what we have, let me just write it over here, is 3x could equal 6, or 3x could equal negative 6. I forgot to write negative though. And now when you divide by 3, you get 2 or negative 2. There you go. Again, pause the video as I go if you need to write anything down. Moving on to exercise 5. Now this time is the first time for number 5 that there's only one answer. All right, and this should make sense because if you were to graph it, absolute value function, there's only one time that the y value is 0, and that's at 0. Another way you can think about it is 0 is neither positive or negative. So it's not positive, it's not negative. So you can't just negate it. All right, now let's make this a little bit trickier. So again, isolate the absolute value. So if you isolate that, your first step would be to subtract 9 over. Well, 7 minus 9 is negative 2. And then divide by 3. Now here's the tricky thing. Can z, I don't care what z is right now. What I know is the absolute value will make it positive. Will a positive number ever equal negative 2/3? No, there is no solution. And again, they're asking you to look at the graph of this. And I'll just look at the graph of this function because I want to keep this pretty simple. If, well, let me use Desmos. Let me pull up Desmos again. And we have this 3 absolute value. I'm going to change it to x though, plus 9. And we're going to see where it equals 7. So as I zoom out, you can see the two functions. Where do they intersect? Nowhere. So there's no solution. That is all we're looking for there. And without even getting into any work, look at exercise 7. We have another positive equaling a negative. No solution. Don't even bother trying to do anything. This is impossible. Again, you can use that symbol for no solution. That is fine. With our last two problems, you don't get confused with this. Don't get too bogged down. Because there's a lot of scenarios, but the scenarios actually overlap with each other. The first scenario is that both insides could be positive. The other scenarios is they could both be negative. Well, if you negated everything here, it's actually equal. Like if I were to do negative 3x minus 2 equals negative 5x plus 8, you could get rid of all of those negatives in this positive by multiplying by negative 1. So that's sort of a waste of time. So the other scenarios is just to negate one of them. So I'm just going to negate the first one, negative 3x minus 2, and leave the other one positive. And you could have done the flip-flop of that, and it would be the same scenario where if this were negative 5x plus 8, you would leave this one alone, 3x plus 2 is equal to what I just wrote there. So those are your two scenarios. I would subtract 5x to the left side and subtract 2 to the right side. Well, 3 minus 5 is negative 2x. Negative 8 minus 2 is negative 10. And divide both sides by negative 2, you get x equals 5. Or this other scenario, but the work is the same, like subtract 5x to the left side, and this time you add 2 to the right side, to cancel these things out. So you have negative 8x is equal to negative 6 And when you divide by -8, you can reduce that to be +3/4. So you guessed it, we're going to Desmos to see what this looks like. So again, let me just delete that. Absolute value of 3x minus 2. Let me double check I'm doing that right. 3x plus 2. It's good to check your work. And then this one, again, absolute value of 5x minus 8. You can see, if I move my screen and zoom in a little bit, actually I don't want to zoom in because one point of intersection is at x equals 5. The other is at 0.75, which is 3/4, which is what I said. See our two x values? They match up there. So hopefully that makes sense why you have to negate one and not the other. And you don't have to do all 4 scenarios, you know, because this could have been positive, this could have been negative. Both could have been positive, and both could have been negative, because all the work would be the same. So let me just show you with this one. Sometimes I just leave it alone, and then like x minus 2 equals 8 minus x. Or negate one of them. I usually negate the one on the left. Leave the one on the right alone. So as I add x to the left side and add 2 to the right side, I get 2x is equal to 10. And when I divide by 2, I get x equals 5. But then on this one, as I add x to the right side, everything cancels. And I get 2 equals 8, which is not true, so this is sort of a moot point. So let's look at Desmos again, just to double check that we understand. Absolute value of x minus 2. And then absolute value, I think it was 8 minus x, wasn't it? Let me double check. 8 minus x, yeah. So as you look at the points of intersection at x equals 5, but then it's parallel for everything to the left of that, and it's parallel for everything to the right. So x equals 5 is the only answer. And now you are ready for the homework right here. And don't forget, you can rewatch these videos as often as you want.